Bismillahirrahmanirrahim. In the last session, we have discussed section 4.2 related to electrical quantities for IGCSE and O level physics course. And in continuation from the previous sessions, now we're discussing the remaining part of this section. So starting from this page 198, put this into practice. So this is Hodder's book, from which we have discussed all these things in the previous lecture, which is available on this channel, and now we are going to discuss this from now put this into practice, page 198. Here we have the current flowing through a resistor is 0.30 ampere when a potential difference of 4.5 volt is applied across it. So we are applying 4.5 volt potential difference across a resistor, and a current flows through that resistor is 0.30 amperes. Now calculate the value of the resistance. So we have given the current and we have given the voltage potential difference that is applied across that resistor. So the resistance can easily be obtained as R is equal to V upon I. So V is 4.5 volt and current is 0.3 ampere. So that is 4.5 divided by 0.3 is 15 ohms. So this 15 ohms is the result. Secondly, a current of 0.2 amperes flow through a resistor of 10 ohms. The resistance is 10 ohms and current flows through that resistance is 0.2 amperes. So calculate the potential difference across the resistors. So the potential difference has to find. So V is equal to IR. So I is 0.2 ampere and the resistance is 10 ohms. So the 10 multiplied by 0.2 is 2 volt. A potential difference of 12 volt is applied across a lamp of 24 ohms and the lamp lights up. So lamps glow. So 12 volt is applied across 24 ohms. So calculate the current passing through the lamp. So voltage is given and resistance is 12 ohms and I has to find. So I is equal to V upon R. So 12 volt divided by 24 ohms is equal to 0.5 ampere. So we have given this. So V is equal to IR. It can be I is equal to V upon R or R is equal to V upon I. So here we have this R is equal to V upon I, V is equal to IR, I is equal to V upon R. So this is simple. Now resistance of a metal wire. The resistance of a metallic wire increases as its length increases. If the length of a wire increases, the resistance increases as its cross section area decreases. If we decrease the cross section area, then its resistance will increase. So depend on the material. So what type of material we are using, either silver, iron, copper, aluminum. So this every material has its own resistivity. So now we are discussing the test yourself, page 199. What is the resistance of a lamp when a voltage of 12 volt across it causes a current of 4 amperes? So we are applying 12 volts and current, it causes a current of 4 amperes to flow. So we have to find the resistance. So the resistance has to find V is equal to 12 volt, I is equal to 4 amperes. So resistance is equal to V upon I. 12 volt divided by 4 amperes, 3 ohms. Calculate the potential difference across a 10 ohm resistance carrying a current of 2 amperes. The current is 2 amperes, resistance is 10 ohms, so V is equal to IR. So this is 20 volt. The potential difference across a 3 ohm resistor is 6 volt. The resistance is 3 volt and the potential difference across this resistor is 6 volt. Calculate the current flowing in amperes. So R is or V is given R and V is given 3 ohms and 6 volts. So I is equal to V upon R. 6 divided by 3 is 2 ampere. Calculate the number of coulombs per second passing through a 4 ohms resistor connected across a terminal of 12 volt battery. So we have given the resistance and we have a voltage terminal battery. So I is equal to Q upon T, and basically I is equal to V upon R is this 12 volt, and this ROM is 4 ohms. So 12 divided by 4 is basically 3 amperes, and so this is 3 amperes is basically coulombs per second. So this is also known as coulombs per second. Ampere is also a coulomb. Ampere is equivalent to coulombs per second. So 3 ampere is equal to 3 coulombs per second. Now put this into practice, because I is equal to Q upon T. So this is Q and this is T. So coulombs and seconds. So from this equation. Now put this into practice. Page 1200. A certain wire has a length of 10 meters and a resistance of 6 ohms. Calculate the resistance of 20 meters of wire. So if length is 10 meters, the resistance is 60 ohms. 60 ohms for 10 meter wire, and we have to find the resistance of 20 meter of wire. If everything is same, then it will be just double. So the length is double, so the resistance will be double. So let's we actually solve it. It says R is proportional to length. So if length is double, then the length, if length is double, the resistance will be double. So R2 divided by R1 is equal to L2 divided by L1. So R2 is equal to L2 upon L1, and R1 is here. So L2 is 20 and L1 is 10, and this is 60. So this is simply multiplication. So 120 ohms. This is simple. So 120 ohms for length 20 meters. A certain wire has a diameter of 0.2 mm and resistance is 60 ohms. Calculate the resistance of the wire of the same material with a diameter of 0.40 mm. So this is diameter 0.20 mm, and if the dia is just double 0.40 mm, so we have to find the resistance. So this is R1, which is 60 ohms. So this is 60. So unfortunately we have not used this 60 but 6. So if we use 60, then it would be 15. So let's solve this. Assume this is 6. So if this is 6, then it would be different. So 60, if you place 60 here, then we write a 0 everywhere. So R is inversely proportional to 1 over A. So R is equal to some constant, proportional constant 1 over A. So in this way, this inverse relationship could be used. R2 is equal to A1 upon A2, because this is inverse relation. This is used like this. So this is R1 A1 and R2 A2 will be same. So because when we use this cancellation, so we use some constant. R is equal to K upon A. So A and this A and R will multiply on side, and this constant becomes constant. So this is same, and we will use this relation to rearrange it. And then R2 is equal to A1 upon A2 and R1. So in place of this A1, we will use this pi r square. This is area of cross section. So this is dia, so we divide this by 2 to make it a radius. Similarly for this one, and then square, and it will eventually, this 2 square and this 2 square will cancel out, so 0.2 mm square and 0.44 mm square will be there. So this is r1, and this pi will also cancel with each other. So this is simply 1 over 2, and this is 1 over 4. So this is resistance is simply 1/4 of the given resistance. So if this is 60, then it would be 15. If this is 6, then it would be 1.5. So for 60, it would be 15. Just assume it 60 and it would be 15 ohms. Nothing else. Test yourself. Sketch the IV graph of a resistor of a constant resistance. So this is a ohmic resistance. So if for ohmic resistance, the sketch is always a linear straight line. Theoretically, at least, it is same. Practically, it may have some other effects, may have a slight variation, but it's very close to the straight line in practical situation as well. How could you obtain a value of resistance from the graph? Simply we divide by I. So we will divide the voltage by a current and we will get the resistance. Sketch the IV graph of a filament lamp. The filament lamp has after some point it gets saturated. This is not a straight line, but it's a non-linear relation. So this is a graph of filament lamp. Explain the shape of the graph. Filament lamp is a non-ohmic conductor at high temperature. At high temperature, after when more current flows, it gets heat up, and at that time it shows a non-ohmic conductor and at high temperatures, and filament lamp of IV graph curve flatten as Vi increases. So voltage and current increases, it's flattened. It's not a linear, it's rather flattened. As shown in figure, that is the resistance V upon I increases as I increases and makes the filament hotter.